Colleagues, welcome back to the office and to our presentation for today. And we will be discussing artificial intelligence inside of your organization. AI is one of these topics that is becoming so important and critical and relevant into today's business environment because it's become so pervasive. It's becoming something that is widespread, even something that even small mom and pop corner shops or your professional accounting practice can employ and utilize. In this series of courses, what we're going to be looking at are the major tools and techniques that can be utilized inside of AI, some of the major components that you might want to consider utilizing, including applications, platforms, and more. And today we will be taking kind of the overview look of AI, understanding essentially what this important technology is and how it can function inside your business. And then hopefully how you can ultimately implement inside your business and gain some efficiencies from these incredible tools. Now, this kicks off our series on this topic, and we will have at least 3 episodes that I can think of, 2 in the next today and in the next week or so, and then we'll have another one a little bit later on. But what we're hopefully going to be able to do with this class is give you a pretty good understanding of where and how these technologies are used, and then give you the tools necessary that if you choose to want to implement these technologies, you could. So today, what is artificial intelligence? We're going to talk about some of the major components: machine learning, natural language processing, deep learning, as well as an understanding of statistics and analytics. Don't worry, we're not going to be crunching any math today, but giving you a sense of the different types of analytics are used will help you have an appreciation for where AI can help your organization. There's 3 major business components, from insights to engagement to decision making and more, that we can use with this. But a lot of it comes back to analytics, and giving you a sense of what types of analytics are available will hopefully give you ideas of where you could fit this into your company. In our next episode, we're going to go ahead and discuss and review where AI is being used in today in tools you're already using. So for example, many of you are probably already using Excel, Power BI. You might probably are using productivity tools such as Google Chrome or Microsoft, other Microsoft tools. So where can you utilize AI inside of those components, and what can you leverage inside of those components to use AI? In our 3rd episode, we're going to talk about machine learning tools that can help your business, and specifically going hands-on with some specific AI tools, some more advanced tools, including things from Amazon Web Services, Microsoft, and others. But hopefully between these 3 episodes, and who knows, there might be a 4th, you'll get the tools and knowledge necessary to be able to implement AI in a meaningful way inside your business. All right, without further ado, let's go ahead and get started. But before we do, one quick word again, as a reminder: if you are a financial professional, you can earn CPE credits for watching or listening to our podcast for today. After watching or listening, head on over to cpetoday.com. You'll complete a quick 5-question quiz discussing and reviewing what we are going to cover in today's session, and then you'll earn a credit for today's class. Today's class code is WAI1. Again, that is WAI1, and you can find that course and content at CPE Today. If you are a new watcher or listener to the CPE Today podcast, thank you so much for being here. How about you get a free CPE credit on us? You can get today's class or any other podcast of your choosing by using one free podcast at checkout, and enjoy credit on us, and hopefully you'll come back and find some more content that you'd like to use. Alrighty, let's go ahead and get started now and get right into discussing this incredible topic. Now, artificial intelligence is not a defined one principal thing. It's not like one technology. It's not from one vendor. It's not one particular solution or platform. It's a whole collection of different products and services and platforms and tools. And in a lot of ways, it is a category with lots of different examples of how this particular category can be used. And it encompasses software, it encompasses platforms, it encompasses business processes, it encompasses a lot of different things that you might consider utilizing inside your organization. But let's go ahead and try to get a more finite definition, okay? So Computer science, by its more strict sense of the definition, categorizes AI as the research of intelligence agents. So that really kind of means any device, and device is very inclusive here. So computer program, software, a hardware application or more that perceives its environment and then take action against its environment to maximize successful achieving of goals. So in the sense of AI, you've got a computer program, something that's not living, so not biological, that has a specific objective that will work towards achieving that objective and maximizing its potential. That objective could be resolving customer complaints. It could be making recommendations on what to watch on Netflix and more. Okay, so we program these things to ultimately achieve a specified end game, whatever that end game might be. Now, colloquially, the term AI, we use it really to describe a different set of requirements that aren't necessarily coming into the strict sense of AI, but really kind of like what society perceives AI to be. And really kind of like in society, we consider AI to be programs or machines that mimic cognitive functions that are associated with human minds, specifically the concepts of learning and problem solving. So, colloquially, what we're talking about is creating computer softwares that can mimic what we are thinking and the way that we think. Maybe not the exact thing that we're thinking, but achieving a similar end in a similar way that a human mind would operate. It's two central principles of this is learning, taking inputs, understanding those inputs, and then being able to recall those things that you learn, those inputs at a later date, and then being able to apply them in new and creative ways. And ultimately, what we're looking to do here is solve problems. So, if you think about how you learn, you take a series of inputs, think about all your years in high school and college, and then all of the years on the job. You're going to be presented with a new set of inputs at some point, and you apply those things that you've learned ultimately to solve a new set of problems. And that's what we're talking about with AI here, is ultimately achieving some sort of goal through learning and problem solving and having a computer being able to do those for us. Now, AI has lots of really kind of interesting business applications. It can be used in a ton of different ways. And there are businesses all over the world that are using AI in serious manners inside of their organization. And you don't really have to look hard to be able to find examples of those companies and the things that they're doing. In fact, if they're in the Fortune 500, Fortune 1000, they're using AI in some way inside their organization, from oil and gas exploration companies to retailers to tech giants and more. Here are some just common things and some common businesses that you're probably interacting with on a regular basis that are using AI inside their company. So Alphabet, Google, uses AI all throughout their organizations. They do everything from the self-driving car, their Waymo project. If you're familiar with the CAPTCHAs across the internet, like when you have to go to a website and you log in, they pop up a thing and it asks you to click on all of the fire hydrants or recognize the crosswalks or the storefronts or motorcycles. Well, Google is using that, which is a form of machine learning, which we'll talk about here in a minute, to give data to its self-driving car project, Waymo, which utilizes AI to ultimately be able to navigate the streets of any city in the world without necessarily having to have a driver drive the car that can do it on its own. Well, we're all helping that through those CAPTCHAs. We're telling the computer what to look at when it is a fire hydrant or a motorcycle or something else of that nature. And so that's one example of how AI is being used today. Google also uses this to power a lot of their search results. They're looking for intent. What are you intending to find? What is the real meaning of what you're looking for, and trying to find the most relevant result for you. To their personal assistant, Duplex, Google Home, and more. You're probably interacting with Google every day. At least I know I do. I tend to search several hundred things a day, and I'm guessing most of you do as well. Amazon uses AI to power everything from their Alexa digital assistants to making product recommendations and more. I'm guessing most of you have bought something on Amazon at some point in time. You've probably seen other customers purchase down at the bottom. Well, guess what? A lot of that comes from machine learning, and it comes from AI that Amazon has developed to ultimately create recommendations that will drive people to purchase more and ultimately have an impact on the bottom line and create more revenue for the company. Microsoft uses AI throughout almost all of their products now. Windows is loaded with AI tools such as Cortana, again, to help you find what you're looking for. They even have dedicated tools that you can choose to use in your business, such as Power Automate, which is a tool that has what's called robotic process automation inside of it that can do things like extracting invoice numbers and line item detail out of vendor invoices. In fact, we'll talk a little bit about RPA here in a little bit, and you can check out the Data Sharing and Integrations series of courses from CPE today, where we go into Power Automate at a much deeper level and showing you how you can use some of these AI tools from Power Automate. Apple uses AI to improve security. If you happen to have a later generation iPhone, it's got Face ID. It can look at you and unlock the phone automatically. Well, guess what? A lot of that is being powered by what is called computer vision. And it's being processed through a variety of different algorithms to ultimately determine, is this person who they are? And if so, let them in. Facebook uses AI all across their platform, from the advertisements that you see to the news stories that get published and more, much to the chagrin of many people. And they've actually been subject to multiple different lawsuits and congressional hearings recently, in fact, in a lot of ways due to how their AI can promote certain agendas. So all of these companies and more, these are just the heavy hitters. These are the ones that you can easily find. They're leveraging artificial intelligence to help their businesses grow. And, there's a reason why they're all, at least the companies listed here are a significant component of all of tech. There's a reason why they're so big, and it's because they're harvesting data from their organizations, processing it. They're finding new ways to grow, and a lot of that work is on the back of machine learning, artificial intelligence, deep learning, and more. Now, I know I listed primarily tech companies here, but I will point out artificial intelligence is not just limited to technology companies. Oil and gas companies, Shell, Exxon, BP, and more, they use machine learning and big data projects to determine oil fields where they're going to go drill. Retail companies like Walmart, for example, analyze millions of transactions a minute to determine what to sell, what to price it, what to put in each store, what to stock. Companies like Delta, American Airlines, and more forecast what flights they need to have and what paths they need to have based off of consumer demand to anticipate when to start, offering certain flights depending on the time of the year, so that they can maximize their revenue potential. Companies, will use artificial intelligence to find new and innovative ways of being able to offer and market their services to their customers. So, from a practical perspective for your organization, you could find ways to market better and more effectively to your customers, how to cut costs, and how to be more effective and efficient with your purchasing and manufacturing. If you're a firm, understanding what clients are adding value in comparison to what firms are easy to work with versus not easy to work with. We can use AI to kind of be our cognitive tool to help us understand and to make good decisions going forward. And even in some respects, to actually do some of the work for us. In a future episode, we're going to talk about cognitive engagement, where some of these tools can do things like answering customer support questions, processing of orders, recognizing potentially fraudulent transactions, and more. So I would tell you, it's a really good time to be thinking about different ways that you can leverage this tech inside your company. Now, let's spend a minute and let's go ahead and discuss some of the major components of artificial intelligence, specifically in terms of categories. There's what we call narrow-focused AI, general AI, artificial superintelligence, and more. And then let's talk about some of the major operating building block technologies that are in the pyramid of AI, including things like natural language processing, machine learning, neural networks. All of these components are major categories that make artificial intelligence artificial intelligence. So our first main category that we're going to want to discuss today is narrow-focused AI. Okay, narrow-focused AI is AI that is designed to perform one thing and one thing only. It's designed to check the weather, be able to play chess, analyzing raw data, or something else, but it is not broad AI. It's designed to do one thing and one thing only. A good example of this is going to be services like Amazon Alexa, Google Play, Apple Siri, and others. While these things kind of seem magical, the fact that I can ask Siri or Alexa or anything, and it always seems to have an answer, it can point me into the right direction, it really just does one thing. It takes an input and it gets a single response. You ask it a question, you get a response. You get an answer that comes back in there. So these AIs are really kind of designed to do a single purpose, but to do those single purposes well. We've got AIs that can do weather forecasting. We've got AIs that can, for example, play games. There's even tools like GP3 from the OpenAI initiative or Jarvis AI, which we'll talk about later on, that can take data and produce writing for you that is pretty good. Now, it's important to note that with respect to these narrow focus AI, they're not conscious, they're not sentient, they're not driven by emotion in really kind of any way in this that we are as humans. They operate within a predefined range, even if it appears to be a lot more than that. Again, these services can seem magical, but they do one thing and one thing only. Now, what's nice about narrow-focused AI is that it really kind of gives us the ability to have a machine that can relieve a lot of the boring, routine, mundane tasks that, frankly, humans don't want to do. We design it to do one thing, and we optimize it for that. So that chess-playing robot is not necessarily going to, rise up and conquer humanity. It's just going to play chess really well. Or if the Jarvis writing robot, we can feed it a bunch of input and it can come out with some really good writing. But again, it's not going to go out there and do math. It's not designed to do that. We have tools that can be used to take and process and harvest data, produce meaningful charts and graphs. That's what they're designed to do. Now, pretty much every single thing that we have out there today in the market, with the exception of maybe a very few research-focused projects in colleges and universities around the country and in research labs across the country, they're all narrow-focused AI. That's it. So everything that we're seeing out there today is designed to do one specific type of purpose. It's not sentient. It's just there to do that one thing and that one thing only. Okay. So narrow-focused AI is what dominates the landscape today. However, if we kind of go up the AI pyramid here, we start looking at bigger forms of artificial intelligence. We have what is called general artificial intelligence, or strong AI. Now, strong AI refers to machines, computer programs here, that exhibit and mimic human intelligence. Strong artificial intelligence, when it is created, will be able to perform any intellectual task that a current human being can be. Okay. So with strong AI, it's not just about doing one task and one task only. It will have the ability to mimic and be equivalent to human intelligence as it stands today. And it will be able to do any cognitive task that a human can do, this computer program could do. So, you could have it, but still it'll be focused in generally probably a couple of areas, so you'll have like a general AI that can, process tax returns and have the understanding of the entire tax code simultaneously in its memory. But that strong AI in tax probably won't be able to, go out and, build a building or figure out the best method of processing, planting corn in a rancher or farmer's fields. They'll be focused still in one general area, but it'll be able to perform the cognitive tasks of that area very, very well. And currently, even today, machines can process data faster than any human can. Your just standard phone has more processing power than what the astronauts had in the Apollo moon computers to go all the way to the moon. We have in our palm of our hand now. And if you look at just the chips inside of it, the microprocessors, they're performing millions and sometimes even billions of calculations every single second. So they're already faster than us. But we have a cognitive advantage over computers. We have the ability to be able to think abstractly. We have the ability to strategize. We can tap into our thoughts, memories, emotions, and ultimately make informed decisions with creative ideas. Okay? So this particular type of intelligence makes us superior to machines and is really kind of hard to define because it's a soft thing. I mean, how can you quantify a memory? You can't, or experience for that matter. I'm thinking of like some of the seasoned auditors that are out there that have audited thousands of times and looked at, hundreds of different businesses over their careers. They can process and understand things much better than a computer can just based off of their intuition and understanding from their experience. And so at the moment, this is something that we can do that is really, really, really difficult to be able to mimic inside of a machine, the idea of this experience in memory. However, with strong artificial intelligence, it's expected to be able to reason, to be able to solve problems, to make judgments under uncertainty, plan, learn, record, integrate prior knowledge into decision making, ultimately to, again, kind of mimic that human behavior. General AI doesn't exist at this point. Probably won't exist for 10 plus years. It could probably never exist too. There might be some literal hard limitations to the physics that it just, at least under our current understanding of math and how the world works, we might not even be able to make stuff like this in the future. But I will point out this type of AI is actively being researched and pursued all over the world by all different types of businesses, and even some nation states and governments have multiple different research programs designed to see if this is possible, and if so, be the first to create it. Now, I think where a lot of people get nervous with respect to AI isn't really in the Alexas or the chess playing robots, or even stuff that can pack and load trucks using physical robotics. It's this idea of superintelligence. With superintelligence, it's this idea that we can create a robot, a bot of some sort, either a physical robot or just something that exists inside of a computer that could surpass us. That essentially we become slave to the robot in some way. And the idea of superintelligence is creating of a bot that surpasses human ingenuity and intelligence in all aspects, from creativity to general wisdom to problem solving. It's better, faster, cheaper than any type of human being, and capable of the same computer robot, from painting a masterpiece to solving the mysteries of the universe, being the smartest thing that ever existed, far beyond what we as human beings could probably do. And this is the type of AI that a lot of people are worried about. For example, Elon Musk has famously said that he thinks AI could be the extinction of the human race. He believed this so much, he actually started an initiative called the Open AI Project to kind of, let's say, pioneer in the AI field to hopefully prevent something like this from ever occurring. And just like with general intelligence, it doesn't exist. This is something that doesn't exist at the moment, probably won't exist for 30 years, probably won't exist ever. There are a lot of really big technology hurdles, things that physically might not be possible, that we would have to overcome to really kind of make this a possibility. And we don't even know what the questions are at this point. So this is not something that is possible, at least as under our current understanding today. Now, with superintelligence, there's this also kind of converging idea of what we call the singularity, which again may or may not happen. This is a hypothetical point in the future at which technology growth becomes uncontrollable, irreversible, resulting kind of in unfathomable changes to human civilization. The singularity is that point in time in which the technology we have created becomes self-aware, self-learning, self-improving, and autonomous, essentially no longer under our control. It's capable of existing and improving without us having to do anything else to it. We birth it, but then it just kind of grows up and does its own thing. The consequences, the existence, the possibility of this are widely debated, contested. It's not widely agreed upon. Some say it could be the end of all mankind. Others believe that, hey, building something like this is our chance to solve unsolvable problems and to take us to that next plane. Where I think this is kind of interesting I'm not a maximalist in this. I'm not thinking it's going to be here anytime soon, nor do I think it's going to be in the way that we perceive it to be. But what's really interesting with the Singularity and with strong AI, I mean, it could be a companion to us. It can help us in ways that would otherwise not be possible. It's also, if you think about, for example, space exploration, at the moment, the furthest we could realistically get to, is the outer edge of our solar system in our lifetime. And that's even then not possible. It's crazy to think that even going to Mars is a realistic possibility here in the next couple of years. But the idea that us as human beings are going to be surfing the stars and navigating the universe is unrealistic at best. However, if we could build artificial intelligence to essentially do that space exploration for us, we could still explore the heavens without necessarily having to leave Earth. So I think it's pretty interesting to see where it's going to come and go in the next couple of years. So this gives you a little bit of an understanding of some of the major topics and levels of AI that are out there. But for the purposes of our discussion for the rest of today, as well as in our future episodes, we're going to narrow our focus to narrow AI. Because that's what we can actually do, and that's what exists today. Let's go ahead and have a polling and review question. Alrighty, so our first polling and review question. Alexa, Google Assistant, Siri are all examples of what type of AI? Well, is it artificial superintelligence? No, it is not. Is it strong general artificial intelligence? No, it is not. Is it narrow focused AI? You guessed it. That is the correct answer. Pretty much everything today. There's not a commercial product on the market that is general AI, strong AI. It just doesn't exist, and superintelligence might not exist ever. Alrighty, so let's go ahead and take a look at some of the major building blocks of artificial intelligence. Starting first with language. So there's a couple of related fields here that I would say are related to getting data into AI and into the actual computers themselves. So with respect to this, if it's something like recognition, like looking at physical paper and being able to pull data off of paper, we call that computer vision. We also have another type of technique that allows us to be able to interact with computers using speech, which I think is really interesting and worth some specific discussion here. And that specific topic is natural language processing. And NLP is kind of all encompassing, whether it be, essentially talking to a computer through our voice, or typing to a computer, or extracting information from a written piece of paper. All of that ultimately comes back to natural language processing. And with NLP, this is really kind of focused on the interactions between computers and human people. Okay. And with this, at its essence, it's a translation service that helps computers understand what a human being is saying, but not just the physical words themselves, but the intention and the meaning behind it. If you think about the nuance of the English language, we have words that can have 10 different meanings sometimes. I think of the word cool as an example. It could mean temperature, and it could also mean something that's, nice, something that you enjoy, and a lot of different things between there. A computer has to have a way to be able to interpret that, both in terms of it being able to understand you and then you being able to understand it. Well, NLP is a topic within this that will take a physical input, whether it be written language, typed language, or more, and then interpret it to a computer. And it's bringing to life a lot of the AI solutions that we see today, making them approachable. It's kind of one of the last mile techniques inside of artificial intelligence. And you interact with it every single day if you're using a tool like Alexa, Siri, Google Home, and more. Now, a building block of AI, and probably I would say the foundational level right here, so at the bottom row of AI, is going to be a topic called machine learning. Now, machine learning is a branch of data analysis that automates a lot of the analytics and models that we use for decision making. And it's based on the idea that systems can learn from data. They can identify patterns, and then they can make decisions with minimal human intervention. And in a nutshell, what we do here is we get a bunch of data, we feed that data to a computer program, we tell it what to look for, we tell it when it's being successful, and then it can ultimately recognize a pattern, and then we can feed it new data in the future. And with that new data, based off of what it's learned, can ultimately make a decision based off of that new set of information. So by its design, for machine learning to really be effective, it has to be iterative, meaning it goes through models, it gets exposed to new data. We train the model to ultimately be able to recognize the pattern we want it to be able to find. And then we give it new data, and then we see if it's able to independently adapt and learn based off of that new data set. Previous computations will become more reliable, it becomes repeatable, and ultimately we're going to get results. Some examples of this: the self-driving car, as I mentioned, through the CAPTCHA system, we will identify, for example, what a dog looks like, what a cat looks like, what a storefront looks like. And then it's able to recognize that actually out on the road without us having to say, yes, that is what in fact it thinks it is. It now, through its experience and its learning, is able to figure that out on its own. The recommendations that you see from Amazon, Netflix, machine learning algorithms. It presents data to people, and every time somebody buys, clicks, it captures a little bit more data and gets a little bit more effective, ultimately figuring out an algorithm that will optimize whatever type of goal it's looking to achieve. In this case, it could be satisfaction, if it's in the case of watching something on TV, or in the case of Amazon, it could be revenue. Presenting X, Y, and Z lead to what type of purchases and what type of revenue generated. And you could do this in lots of different ways. Some people do what's called sentiment analysis, using media and content from social media to understand what people are saying about a particular person, company, topic, to get a sense, broadly speaking, what the society feels about it. We also use this for stuff like fraud detection. Machine learning is the basis of pretty much all fraud detection these days. Companies like the Fair Isaac Corporation, American Express, tons of banks, they've built machine learning algorithms to determine patterns of spending. They have a persona for you. And based off of what you purchase, where you purchase, when you purchase, types of purchases, amount of purchase, they can determine if a transaction is fraudulent or not. Pretty nifty overall. Now, one step up in this AI pyramid, we have another type, which is called deep learning. Okay. And this is a more contemporary topic compared to machine learning. Machine learning has been around for a while now, but with deep learning, this particular subset is the machine learns on its own. It's a type of machine learning that trains a computer to perform human-like tasks like recognizing speech, identifying images, making prediction. But instead of organizing data to run through predetermined equations, deep learning sets up parameters about the data and then trains the computer to learn on its own by recognizing patterns and by processing lots and lots and lots and lots of data. For deep learning to work, really you can't do this on a couple thousand records or even hundreds of thousands of records. Really, deep learning, it's because it's being self-taught and has little to no human interaction, requires vast quantities of information to be able to learn effectively. So, but that's kind of the future of machine learning, is ultimately creating machines that can teach themselves. It's kind of hard, at least when I was initially kind of understanding the differences between these two. But let me compare them side by side for you. Okay, with machine learning, we have a series of inputs, and let's just say, for the purposes of our discussion here, we're trying to recognize what a car looks like. Well, think about that objectively for a minute. A car. Well, are we talking about truck? Are we talking about an SUV? Are we talking about a coupe? Are we talking about a sedan? Are we talking about a delivery truck? I mean, go-karts, motorcycles, I don't know, there's lots of different things. And then even think about within a car, you've got Ford, you got Chevy, you got Mercedes, you got BMW, all different colors. There's lots of things that a car could be. Okay. Well, with machine learning, we will tell the computer and what a car looks like. So we're going to say, it's got at least it's got at least 3 wheels. Okay. It'll have some doors. It should have some rear view mirrors. Should have some color on the paint. I might have a trunk, but we give it thousands, hundreds of thousands of sometimes inputs. In this particular case, probably a picture would be the best. And then we tell it, essentially, hey, all these different things from the Model 3 BMW to the F-250 truck, those are all cars. Well, the inputs get fed in. We do the feature extraction. The computer will then get new input in the future. It will do the classification on its own, and then will ultimately deliver an answer. So if we gave it a new picture of a vehicle, it could then analyze that vehicle and then spit out whether or not what it's looking at is a car or not a car, based off of all the things that it's seen prior. But we're ultimately the ones that instruct it what a car looks like. We are the ones that extract the features and tell the algorithm, the machine learning, what in fact a car looks like. Okay. Now, deep learning, on the other hand, we're not involved at all. That's the big defining characteristic of deep learning. It's a black box in some respects. It gets a whole bunch of pictures of vehicles, of other things, maybe cats, maybe dogs, maybe buildings, maybe spaghetti, who knows? And it figures out and does the feature extraction and classification, ultimately trying to group the inputs into different major categories. And ultimately it makes the same decision, car or not a car. But there's no human involved in this level of machine learning. Machine learning, we're involved. Deep learning, we're not involved. The big reason why, for example, we do machine learning more often than deep learning, quantity of data. Again, you need large quantities of data, reliable data as well. And with machine learning, it's simpler, faster, easier. You can build stuff that's actionable. Deep learning is really, at least at our current understanding of this, is going to be something limited to research, limited to big companies like Google that have resources to be able to not only collect the data, then process the data, then provide action on that data. Now, another topic which is pretty cool that is an expansion on deep learning are what are called neural networks. Okay. And a neural network is like a system of deep learning. Okay. So it's not just one algorithm, one deep learning algorithm. It's a collection of different algorithms and processes all working together. A neural network takes lots of different input types and will ultimately produce a response to you. So a good example of this is like selling of a home. Well, there are lots of different characteristics that go into selling that home to ultimately figure out what to pay for that home or to price that home. Now, let's talk about that traditionally, how you would normally handle that. Well, in a traditional environment, you come up with it on your own. I mean, you're hiring a licensed broker, real estate agent who's familiar with the area. They're going to look at all the different characteristics of the home, of the neighborhood, of the economy to ultimately find the best possible price and a price that home will sell for. Well, let's say a neural network here. Well, that neural network is going to take lots of different inputs. It's going to take, for example, things about the home, like the square footage. It's going to take things about where the home is located. It'll take, for example, context of other similar homes in the area. Okay. It'll take into account big factors such as economic indicators like interest rate, unemployment, and more. And it feeds this information through a variety of algorithms, through a variety of different internal calculations, and then pops out a single output. And this neural network essentially isn't just one thing, but it's a collection of all of these things in decision-making to ultimately get you an answer for your question. And what we're trying to do here is produce a model that can give you a good answer based off of the data that you fed inside of it, a very comprehensive network. So the neural network itself is not an algorithm, but rather a framework for lots of different machine learning processes and deep learning processes to work together to provide an output. And this output will originate kind of in a black box. I mean, the way it makes its decisions can be very difficult to understand at times. I mean, in a lot of ways, it feels like magic, but there's a lot of math, there's a lot of statistics for it to produce its value. Now, with neural networks, they also have the ability to be able to learn and to perform tasks that don't have very specific rules. And they can, based off of the output, you can tell if it's right or wrong. And when you give it that kind of feedback, it gets better and better over time. Now, one of the cool things that neural networks are being used for is in recognition. So in this slide over here, you'll see I've got a picture of a cat. Well, neural networks, for example, not only can recognize it's a cat, but it knows essentially what makes a cat. It's able to identify essentially things about that we didn't have to tell it. So a simple machine learning algorithm would just be able to say, hey, is this a cat or not a cat? A neural network, on the other hand, can look at a picture of a cat and then identify they've got fur, it's got tails, whiskers, cat-like faces. It automatically generates those characteristics from the learning materials and then is able to make, through a variety of different calculations, not only is it a cat or not, but what are the features of this cat? And those features actually tell it if it's a cat or not. Now, if this seems confusing to you, you're not alone. It took me a long time to really kind of understand and recognize these different topics and find different ways that they're applicable. But this type of technology, again, is being used by all major businesses, big businesses around the world. And this is how they're able to gain competitive advantages over their competitors and get so large. They're using algorithms and machine learning and deep learning and neural networks to identify and segment their customers more effectively, to ultimately generate more revenue, cut costs, and to be more effective with their work. Alrighty, let's go ahead and have our second review question. Which are the black boxes of computer learning? Okay, so in the most technical sense here, I would say probably all three of these, machine learning, deep learning, and neural networks, can seem like black boxes. But really, I would say it's going to be deep learning and neural networks as being your black boxes. Mostly just because humans aren't involved in this. They do the work on them on their own. And it's not really kind of possible to like pause that black box and open it up and look and see exactly how it's operating. It's kind of like Schrodinger's cat in some respects. They are programmed and we see the inputs as they come in, and we just have to recognize the outputs as they come out, whether or not they're right or wrong. But for all intents and purposes, they're kind of black boxes in terms of how they operate. Alrighty. So let's go ahead and get into our last topic for today, which are going to be understanding what AI can do for you, and then just an understanding of how those analytics are generated from AI. Now, AI is, again, it's something that's growing, it's expanding. It's something that we're finding and reimagining different uses for inside of our businesses on a regular basis. It's something that almost any process inside of a company can be benefited from by using AI. But there are three big areas that I think you can consider using AI for your organization. Those are going to be in the areas of process automation, which we'll talk about today, cognitive insight, which we'll also introduce today and probably expand further in another episode, and cognitive engagement, working inside of your organization, which we're going to save for a future episode as well. And process automation is going to be stuff like doing back office tasks for your company. And there are a variety of data sharing and integration tools now that'll just do this work for you. For example, interacting with customers, processing of email, transferring of calls, you name it. There's a number of different ways, and we can all benefit by automating those processes inside of our company. It makes everybody's life easier. We have cognitive insight. This is understanding and trying to figure out what customers are going to buy, identifying fraudulent transactions before they occur, automating of advertising to specific people that are most interested in that specific topic. And then ultimately cognitive engagement, interacting with computers like they are human beings. And I guarantee you all have done this. At some point in the last year, you've called a company to get customer service and talked to an AI, probably your bank. You probably chatted with an AI on a vendor's website and more. But AI can find its way in use in lots of different businesses and lots of different business functions. And in the long run, hopefully we can find a way that these services can work hand in hand with our human workers even more than they are at the moment. So essentially we have a robot force, and then we also have a human force as well. And humans are tasked with doing the things that are good and useful for humans, and the bots are doing the tasks that are ultimately better focused on bots doing, but everybody's doing the thing that they should do. Now let's go ahead and talk through the process automation and cognitive insight. Okay. Process automation is going to be automation through users. Okay. And then analytics are going to be helpful in decision-making and gathering of information to ultimately make better decisions. Now, probably one of the most practical examples of where we're using AI today is in a topic called RPA, or robotic process automation. Now, RPA is a form of automation where we have business process robots or bots that are utilizing a variety of different AI techniques. And what they can do for us is that they are able to watch a user work, understand what the user is doing, and then perform that task in the future. And so with RPA tools, we can use this for processing of invoicing, setting up of customer accounts, evaluating a customer's purchasing habits, making marketing decisions, and more. And to be clear, I'm not talking about like physical robots. I'm talking about computer bot programs. And we train these bots to work, and then those bots can do those actions as many times as required into the future. Now, this is in contrast to like traditional workflow automation tools, where a software developer, builds a predefined list of things that can happen. Typically, data is moved between what are called APIs, application programming interfaces. They have to be not only written, but tested, debugged. With RPA, we train the computer program by doing the work, and the computer program recognizes what we do and then can do that action again based off of a new series of inputs. So pretty cool. And RPA is already being used in lots of different examples. It's used all over banking and financing, like credit applications, opening of accounts. It's being used a lot in customer care, resolving customer issues, answering questions. It's being used in manufacturing, logistics as well. A lot of people are using it for processing of invoices and more. The example that immediately comes to mind is Bill.com. Through their service, you can use them to process your accounts payable inside your business. And one of the cool things is that your vendors can email in their invoices to you. They go through the Bill.com process. Bill.com uses an RPA tool to extract, what the invoice from that vendor is. So the date, the time, what was purchased, and then they use that to kick off their automation rules for invoice approval. It's pretty nifty. And a lot of that is built on the principles of RPA. But anytime that you've got stuff inside your business that you can, especially that's repeatable, standard, something that's not really complex, like it couldn't, for example, evaluate artwork here or compose music, you can use an RPA tool to help bring that together for you and to automate that process. We'll talk more about data sharing and integration in future classes. And I'll also point out that you could check out the data sharing and integration courses that we have at cpetoday.com as well. There are a variety of courses that I've produced that talk about different process integration tools besides RPA too. There are tools such as Power Automate from Microsoft, Zapier, Ifit, and more that can be really helpful for automation inside your business. And RPA is one of a larger category of tools in this category. All right. And AI can also be super, super helpful in analytics too. In fact, a building block of a lot of artificial intelligence is analytics, it's statistics, it's math, it's evaluation, ultimately to help people make better decisions. And to really kind of understand where AI can be helpful in this fact, you have to have a bigger picture understanding of how analytics works. And there's really kind of four major categories. Now, the stuff that most of you are probably familiar with are what we call descriptive analytics, and it's really summary statistics about what happened. So think about this in the context of the outcome of your company on a financial statement, okay? Well, descriptive analytics would be used to essentially help you understand what happened, what you sold, what revenue was generated, what costs did you incur, to ultimately hopefully make better decisions going forward. And we can uncover patterns that can maybe offer insight. A simple example, let's just say you're trying to assess risk. Well, you can look at prior performance to determine outcome on future performance. If it's an indicator of what happened in the past, might be an indicator of the future. Well, you can look at what happened in the past to make a decision on what to do with your company. Like whether or not a potential new customer is likely to meet your expectations, to pay their bills on time. They can be helpful in the sales cycle, categorizing customers, categorizing vendors, and more. We have diagnostic analytics. These are used for discovering to determine why something happened. Okay. For example, you can compare financial performance with social media, understanding what people purchased, and then looking on social media to say about what they purchased and how they enjoyed that particular product. So we assess, for example, the words to determine are they positive or negative in context to sales. It can give us a pretty good idea of, why people are buying what they're buying, and what their thoughts are on that particular topic. And this is easy at this point in time. I mean, there's ways of extracting social media information, search engine results, and more. And then we use that information to ultimately create better campaigns, better products, provide better services, and more. And machine learning can process that information for us, giving us those little nuggets of wisdom to focus on. We have predictive analytics. What's going to happen? Okay. This is probably where we start to see machine learning kick in a lot, where it can run various simulations, taking into account different types of analytics to ultimately hopefully figure out what is going to be done in the future. And a lot of companies are using predictive analytics for sales and lead scoring. Some companies are using this further to assess their entire sales process, analyzing, hey, based off of where we are as a company right this moment, what can we expect is in our sales pipeline? What kind of money can we expect to be making in the future? They'll take into account social media information, accounting information, CRM information, customer relationship management, and more. Often kind of tuning their models to figure out what the outcome of the company will be based off of current conditions. And really where AI kicks in here is in a method called prescriptive analytics. And this is where it really, really gets interesting with AI, because now we're asking the question of not what could happen, but what do we want to happen and how can we make that happen? With prescriptive analytics, this is where big data and AI all come together, and it gives you laser focus to be able to answer specific questions. Here's a simple example. In the healthcare industry, you could better manage patient population by using prescriptive analytics. You can look at things, for example, your patient's health, the obesity. You can add filters such as do they have diabetes, cholesterol, age. Using this information ultimately kind of help focus better treatment. So if I'm trying to produce X, Y, and Z in a patient, maybe a specific type of health criteria, weight loss, improving specific test results for specific treatments like cancer or something else of that nature. Well, prescriptive analytics can help us. If we know what we're looking for, we can then figure out the steps along the way to make that happen. And this is kind of like having a crystal ball in some respects. It allows us to know the outcome of what we're looking for and then figure out the ways of making that occur. And it's pretty cool. I can tell you that some big businesses will use this very similarly in their customer. Hey, here's the level of revenue we're looking to generate. Well, the prescriptive analytics, you can work back from there. Okay, if I want to get to this level of revenue, here are the types of things I need to do in my business. Either cut costs, or sorry, not for revenue, but for profitability. I either need to, find these types of customers, sell these types of products, market them in this particular way at this particular price point, and more. And with prescriptive analytics, we kind of bring it all together under one roof. We've got AI, machine learning, big data. Often we're processing large quantities of information. And in order to really kind of make this possible, that AI piece really is sitting in the middle here that's bringing it all together. And so, it helps us go up the value chain here from predictions to decisions to effects. What will happen? How do we benefit from those decisions? How can we ultimately make things happen for our business in some ways? Well, machine learning, deep learning, neural networks give us the ability to be able to process this data in a meaningful way to get that outcome of what we're looking for. And this is a building block of AI tools, is understanding and processing data. Now, this might seem like it's way out there, at some point in the future. Well, it's really not. Businesses are using prescriptive analytics today as well as a building block of their decision-making in some respects. Venture capital companies use prescriptive analytics about their investment decisions, understanding things like return on investment, management of risk inside the portfolio versus reward. They figure out essentially if they want X amount of return, what type of things they need to invest in and what collection and what categories and percentage of their portfolio. Companies use this for lead scoring and understanding what type of customers to recruit inside their organization. Companies like Facebook, Reddit, and others use algorithms to make recommendations on what type of content to be presented, to focus on eyeballs on screen and keeping you there as long as you possibly can. Facebook, TikTok, your social media networks are incredibly good at this. Banks use this to detect and deter fraud. By creating an algorithm that is not so tight that it blocks every single transaction, but not so loose that they have an unacceptable amount of fraud losses inside their business. Businesses use this for product management, deciding what products to develop, what to improve, what to keep, what not to keep, what prices to sell these, and more. Marketing companies use this for automation, for lead generation, for processing of information through their systems to ultimately get people to engage and purchase. But prescriptive analytics are really where rubber meets the road with artificial intelligence, especially when it comes to, let's say, business success. And I look forward to being able to explore those topics further with you. All right, folks, we are just about out of time and towards the end of our presentation for today. Let's have our third review question. What type of analytics focuses on answering the question of what happened? Okay, so if I just want to understand what happened, what would I be doing here? Well, the correct answer here is descriptive analytics. With the descriptive analytics, we're really just trying to answer what happened. It gives us answers to common questions: who, what, when, where, why things are the way they are. It's that descriptive analytics. It's not until we get to the prescriptive analytics, very close in name, at least to descriptive, but prescriptive, that we're really kind of putting all of our processing power into our data to ultimately influence and get the objective that we'd like to achieve. Alrighty, so what did we learn today? Well, today we talked about the different types of artificial intelligence, the narrow-focused AI. We talked about the general artificial intelligence as well as superintelligence and maybe even the singularity and more, and what their intended purposes would be. Okay. And then we also went in and we took a look at the major different building blocks of AI, including natural language processing. We looked at machine learning, artificial deep learning. We also looked at neural networks and more. And in future episodes of this series, next time that we come in, we're going to look at different AI functionality and tools you probably are already using, specifically tools like Excel, Power BI. There's tools for your internet browser, websites and services, and more. But I'm going to walk you through some of the major category functionality that you can find in tools you're probably already using today. And in future episodes, if we choose to continue this series here, we'll also do some tutorials. I think this might be fun, using machine learning, giving some different examples of how you can use data inside your business to make your business achieve specific objectives. So stay tuned. Now, if you made it all the way to the end, I hope you enjoyed my discussion and presentation today. If you're a CPA or an EA, you want to get some credits, great. We'd love for you to get them as well. As a reminder, you can get those credits from cpetoday.com. Today's course code is WAI1, WAI1. With your purchase, you'll get a CPE certificate. You'll also get copies of the learning materials. You can ask questions and a whole lot more. If you are a new watcher or listener, thank you so much for being here. Why don't you get a free podcast on us? Pick whatever you'd like, maybe today's class or something else, and use one free podcast to check out for a free credit. Now, if you liked our content and you're not a CPA, great way of supporting the channel is to consider following us on social media. You can find us just about everywhere as CPE Today, Facebook, Twitter, Instagram, and more. And you can always get our show on your own schedule, Apple Podcasts, Spotify, SoundCloud, and more. And you can watch or listen on your own time, whatever you'd like. Maybe you're on the car ride home from work or to the office. You can find and learn something new today. We'd love for you to leave a review. It's a great way to spread the word about the show and hopefully find some new listeners. Thank you so much for your time and attention today. It is always my pleasure to present this content to you, and I look forward to seeing you back in the office the next time around. Take care.